So this reaction, and the last one we'll be going through, is esterification. So esterification is the conversion of a carboxylic acid and an alcohol using an acid catalyst to form an ester. So here we have it written out as a carboxylic acid, an alcohol. We have this acid catalyst, which is usually H+. Sometimes it's H2SO4, sulfuric acid, but most of the time H+, to create an ester, and 2 hydrogens and an oxygen, so water. Now water is always a byproduct of esterification, and when I do this example down here in a minute, I'll show you why. The reaction is reversible. We're not going to go into the reverse of getting it back because it's quite complicated and it's not necessary for you to know that, but I have put in my arrow like this to indicate that it is a reversible reaction. So down here we have ethanoic acid, so a carboxylic acid. Then we're adding an alcohol, which in this case is ethanol. 2 carbons along ethanol, 2 carbons here, ethanoic acid. We've got our acid catalyst here as H+. Now we need to decide what our final product of this esterification is going to be. So it takes a bit of remembering of how to name esters and how to draw esters. But you will notice that I've written my OH like this. That is because this acid catalyst comes along and is able to break this hydrogen bond, meaning this O is what creates our ethyl link. I don't know if you remember from when we talked about esters, there's always that ethyl link, that O by itself, something on one side and something on the other side, which there will be in this ester that we form in a second. So in esterification, substitution will always take place right here with this hydroxide. So we always know that this hydroxide is going to the byproduct. So we can proceed by drawing our ethanoic acid as we had it, CH3C and double bond O. Now we've said that this hydroxide is going to get substituted out for this ethanol. We need this O to create our ethyl link. Because this hydrogen here is broken off this also goes to our byproduct. So now we have a hydroxide and we have this hydrogen. That leaves us with H2O, as expected, water. So we always have water over here as our byproduct. So now that that's gone, we simply just take everything that's on this side of that O and add it in where our ethyl link was. So I've got CH2 and then I've got CH3. And now we have our ester. Now for naming the ester, hopefully you remember. If not, we always remember to split it right here at the ethyl link. We name it in 2 parts. So first we name this part with the suffix YL. So 1 carbon, 2 carbon will give me ethyl. Over this side we've also got 2 carbons, and we remember our suffix for esters, O8. So we will have ethyl, ethanoate. So that is the basis of esterification reactions. It won't get more complicated than that. So if you can understand that we always substitute in our alcohol at the hydroxide, and this hydroxide alongside this H form our water, everything else you've got left is right here after your ethyl link O, and you can add it on. So whether this was pentanol or butanol, no matter how long the chain was, you'd simply just add it all there, obviously going backwards, CH2, CH2, and your CH3 being on the end. And that is how you do esterification reactions.